Hi and welcome to another lesson in the physics video series. Today we will be discussing the effect of the resultant due to the varying angle between concurrent forces. We're going to apply two forces to an object and we're going to look at the angle between them and how we will go from 0 to 180 degrees from the maximum effect of two vectors to the minimum effect of the two vector forces. We're going to use this Mickey Mouse watch to help us, and this watch is a classic example where each arm is a vector. Alright, let's get started. As you can see here, I've outlined four important angles. 0 degrees as the maximum, 30 degrees, 90 degrees is the hypotenuse, and 180 degrees is the minimum. We're going to take a look at each one of these angles in particular. When there are 0 degrees between vectors, you're going to get the maximum effect. And if you're dealing with forces, the two forces will combine so that 0 degrees between each vector creates an addition of the two vectors. This is very similar to the airplane problem where the wind was pushing the airplane in the same direction it was going. It was an additive effect. We can see the Mickey Mouse hands magnified here, and they're both pointing in the same direction. So one vector is represented by a green vector arrow and the other vector is represented by a blue vector arrow. When there's 0 degrees between them, you can translate one of these arms in front of the other. Here's green, here's blue, and the sum total, which is this black resultant, is the net force, meaning the total force of the green plus the blue. Both hands point in the same direction, so you simply add the vectors together. That gives you a maximum effect. 0 degrees produces the maximum effect. So here we have a 30-degree angle between the vectors, and you can see Mickey Mouse's hands are pointed at two different angles. One I left as horizontal, that's green, and the blue one pointed at 30 degrees between the arms, and we're going to look for the resultant. So in doing this, we use the parallelogram method, and we can see the green and the blue right here. Then I pick a vector. In this case, I pick the blue vector, which is at 30 degrees, and I translated it over all the way to the other end of the first vector. Here is the shadow of that vector that I moved, and then I connected these two vectors in the head-to-tail fashion. To find the resultant, I start at the tail of the green vector, which is the first vector, and I draw it all the way to the head of the last vector, which is the blue vector. You can see this black resultant line is a bit shorter than the full 0 degree green plus blue. So when you start to increase the angle, you start to decrease the resultant. Let's take a look at the next angle. Here we are at 90 degrees between the vectors, and we can see that Mickey Mouse's hands are pointing to the side and up. And in this fashion, I take the upward pointing vector and I translate it over so that I connect the blue and the green in the head to tail fashion. And then to connect the resultant, I start from the tail of the first and I connect to the head of the last. Since both hands point at 90 degrees, they make a right triangle, and the hypotenuse of this right triangle is the resultant of these two vectors, blue and green. This black resultant vector is shorter than this black resultant vector when the angle was only 30 degrees. So as you increase the angle between the vectors, you decrease the resultant between them as well. Now I've chosen 120 degrees between the vectors. You can see that his hands are pointing to your right and up and to the left. When connecting these two vectors with 120 degrees between them, in this drawing here, you have this original vector, which was the green and the blue. Then I translate the vector and move it all the way across from its current position so that it is connected head to tail. To find the resultant, I connect the tail of the first to the head of the last. You get this very short line right here, and this happens to point straight up based on the angles that I've chosen. Now let's compare the length of the hypotenuse at the 120 degrees to the 90 degrees, and you can see that this hypotenuse length is longer than the resultant when the angle between the vectors is 120 degrees. This is consistent with the rule we have been using the whole time, and we have observed the pattern that as the angle increases between the two vectors, the resultant decreases. And finally, here we are at 180 degrees between the vectors, and this is like Mickey Mouse pointing to the right and pointing to the left. Now we know it's a simple subtraction, and we have the green vector pointing to the right, and we have the blue vector pointing to the left, and the difference between them is this tiny little resultant vector, which is the difference between the right and the left. The green vector was longer than the blue vector, so the resultant would point in the direction of the longer vector. And here you can see in summary from 0 to 180 degrees, and the Mickey Mouse watch, the two hands point at the same direction. You simply add the two vectors together to get the resultant. But once they tilt, say to 30 degrees, then of course you have to use the parallelogram method, translate and connect tail of the first to head of the last, and you can see that this resultant vector will be shorter than the 0 degree resultant. Then tilt it some more, say to 90 degrees, and we have the hypotenuse. Then tilt it a little further beyond that, say to 120 degrees, and you have to use the parallelogram method again. And when you do, you get an even shorter resultant. And then finally at 180 degrees, you simply subtract the two vectors. And that's how we use a Mickey Mouse watch to help us determine the magnitude of the resultant between two force vectors, or really any other vectors, when the angle changes from 0 degrees, which is the maximum, all the way to 180 degrees, which is the minimum. I hope you enjoyed this video, and I thank you for watching, and I'll see you in the next video.